Assalamualaikum warahmatullahi wabarakatuh. Welcome to the last example related to vectors application. So here we have a plane that flies through wind that blows with a speed of 35 miles per hour in the direction of north 43 degrees west. Okay, so if I sketch that diagram, it will look like this. It will look like something like this. So this is north and this is west, so 43 degrees northwest, so it's like this is 43 degrees. So the wind is blowing in this direction and the speed is 35 miles. Okay, I'm sorry, the speed is 35 miles. So this is, you can call this as the wind vector. Okay, in still air, the plane has a speed of 550 miles per hour, where the plane is headed in the direction of north 60 degrees east. So the plane is actually going in this direction, north 60 degrees east. It's about this direction. So this is 60 degrees. The plane is going in this direction. So I'm going to call this is vector P, vector for plane. And so find the true velocity of the plane as a vector and its true speed. So what is going on is you will have the wind blowing in this direction. So actually parallel to that, you will have the wind here. So this is the wind that is blowing in this direction. So the wind is coming this way, blowing in this direction, and so you have this vector here. So this is the wind vector, and we want to find the true velocity of the plane as a vector. So there will be a true velocity of the plane. So this is what you want to find. You want to find this one. You want to find what is this vector here. Okay, the resultant vector. So you want to find what is this, and the true speed. So you want to find what is velocity vector, so of the plane, and the true speed. Finally, find the true direction of the plane. Okay, all right. Okay, so we are going to start off with looking at the first component here, which is the plane component. We want to find this vector. So based on this, I can say that you want to find the velocity of the plane as a vector. So velocity is a vector, and this is the resultant vector of p vector plus w vector. Okay, so that is what we are looking to find, and we need to talk about the component of p vector. Okay, so we're going to look at the component of p vector. So here we have this p vector here. So this is vector p. So the component here is x component in this direction and y component in this direction. So this is x, this is y, and based on the diagram here, you can see that the angle here will be equal to 30 degrees. So we have 30 degrees on this diagram. Right, so next, using the Pythagoras theorem, you will be able to find what is x and what is y, because you know what's the magnitude of this. The plane has a speed of 550 miles per hour. So the speed is 550 miles per hour. So that's the magnitude. So then we have x over 550 miles is equal to cos 30 degrees, and therefore x is equal to 550 times cosine of 30 degrees, and that becomes equal to about 476.31. Okay, so that is the first component for vector p, which is component x. Next, you can find what is the y component. So y over 550 is equal to sine 30 degrees. Therefore, y is equal to 550 times sine 30 degrees, and if you plug in these numbers into your calculator, you will get that the value of y is about 275. Okay, so now we will be able to write down vector p as, so this is the positive direction, so we maintain the value as it is, 476.31, and vector y here is component y here is 275. So that's the first vector, vector p. Now we look at vector w, so we'll be considering vector w. Okay, so we're going to study vector w. So this is vector w. Okay, so the direction given is this one. So the direction is in this direction. This is vector w. The magnitude is 35 miles per hour, so that is the magnitude is 35 miles. So the x component is going in this direction. This is x and this is y. Okay, so next what we have is the angle here. So you can say that since this is 43 degrees, therefore the angle that you are talking about is 90 minus 43 degrees, which is equal to 47 degrees. So 47 degrees. Okay, next, using the Pythagoras theorem, we can say that x over 35 must be equal to cos 47 degrees, and therefore x is 35 times cosine of 47 degrees, and this is equal to about 23.87. Okay, so that's the x component. Next, the y component is y over 35 is equal to sine 47 degrees, and therefore y is equal to 35 times sine 47 degrees, and this is equal to 25.6. Now when you want to add up, when you want to write the vector w, you need to consider the direction. So since x is going in this direction, therefore the value of component x is going to be negative 23.87, and the value of component y is going to be equal to 25.6. So now the velocity of the plane as a vector. So now we can find this vector by adding up the components accordingly. So you add up component x with component x and component y with component y. So now we are going to add up. So the result here can be found by adding up the components. So this one, 476.31 plus negative 23.87, the answer is going to be 452.44. Next, for the y component, you just add up these two results that you have here, and you will get that this is equal to about 300.66. Okay, so that is the first question. Okay, we are done with that. Okay, let me just erase some part of this slide. Okay, next what we're going to do is we are going to find the true speed. So that means you are looking to find the magnitude of this vector here. So the magnitude here is going to be found by taking the square root of this value. So 452.44, you square it, plus 300.66 and you square it. So if you punch in these values into your calculator, you will get that the answer is equal to 543.23. So about this value, and the unit is going to be in terms of miles per hour. Okay, so the unit is miles per hour. So that's the true speed, and we are done with that. Finally, find the true direction of the plane. So notice that originally the intention is for the plane to travel in this direction, which is north 60 degrees east. But based on what you have seen from the diagram, the actual true direction is this angle here, because the wind that comes from this direction has somehow pushed the course of the plane into this direction. So now we are looking to find what is the angle of this. So this is the angle, and that represents the true direction of the plane. Okay, so what we're going to do is if you sketch the vector here, so this is the vector, and you already know that the x component is given by this one, so this is 452.44, and next you have the y component. Okay, sorry, let me just erase that a bit. Okay, so this is the x component, so this is the y component given by 300.66. So you will be able to get this angle here. So this angle is given by this one, so you'll be able to get this angle represented by this one by using tangent of theta. Okay, so this is theta, and this is also theta. Okay, so that is a representation. So tangent theta is equal to 300.66 over 452.44. So based on this, I'm sure you'll be able to get that theta is about 33.61 degrees. But we're not looking for theta, we're looking for this angle here, because we want to represent the answer in terms of the same convention used in the example. Notice that the convention used here is related to north some degree and west, and here we have north 60 degrees and east. So we need to write down our answer in terms of this convention. Therefore we need to know what's the angle here, so that we can express the answer in terms of north, some degree, and east. Okay, so since theta here is 33.61, so this is theta, which is 33.61 degrees, you will be able to find this angle that you're looking for, and that is just 90 minus 33.61. Okay, so therefore I can write down the true direction is actually equal to north 56.4 degrees east. Okay, so how do you get 56.4? You will get it by taking 90 degrees minus this theta. Theta is 33.61, so you will get this angle here. The angle that you're looking for here is 56.4 degrees. Okay, that's all for now. Thank you very much for watching.